We all know what metals are, but I don't think most of us spend a lot of time thinking about where they come from. The earliest people would have found metals probably laying around on the ground, like gold, and been like, ooh, cool, shiny. But the thing is, only a few metals are actually found in their pure form on Earth. The key to the explosion of metals was fire, where the rocks surrounding the fire pit would have got really hot, and metals that we know to have a low melting point, like lead and tin, would have oozed out and cooled. The crazy thing about metals that a lot of people don't know is that they're actually mixed into rocks as small chunks of a pure form as the elements, or attached to other atoms and elements in mineral compounds. So anytime you see a rock laying on the ground, there's lots of different kinds of metals mixed into it. The rocks that we see laying on the ground have many components that are called minerals. There are element minerals like gold, silver, and copper that are found sort of sprinkled into the rocks. And then the metals can also be found attached to other elements and compounds like hematite, where 2 irons are attached to 3 oxygens, ferrous oxide, Fe3O4, sodium chloride, NaCl, which by the way is table salt, iron pyrite, otherwise known as fool's gold, FeS2, and quartz, that's silicon dioxide. So rocks are mixtures. So humans got to experimenting. What do the rocks look like that I can actually get the metals out of? What can I do with these metals? How can I shape them to make useful substances? And finally, what happens when I mix metals together? This experimenting led to the industry of early metallurgy. Step 1, find the right rock. Step 2, crush the rocks into sand. Step 3, heat the sand to melt the metals out. And step 4, shape the metals and then cool them into substances. But the problem was, pure metals all have some sort of flaw. Like, for example, we've got copper and gold are pretty and they're shiny, but they dent and misshape easily. And iron and copper are really cool, but they oxidize super easily, which is why we never find them in pure form, because there's oxygen in the air and they just oxidize and then are found in the rocks in their oxidated form, like rust. So in order to fix these pure elemental metals to make them more useful, people realized that they could mix them with elements with the opposite property. #alloys. Are you frustrated that your copper things keep getting bent? Well, add some tin and make it into bronze, like this cowbell from my great-grandma's actual cow. It's still making noise. Are you bummed out that your iron nails keep rusting? Well, mix in some carbon and nickel, and then you'll get some awesome stainless steel that won't rust. Alloying quickly became, and still is, a super popular way to improve the properties of elemental metals to make them more useful to us. Like most silver jewelry is actually sterling silver, which is copper and silver mixed together. Gold is another situation where pure gold is pretty but super soft, and it's not useful to make jewelry out of. So most gold is mixed with other elements like palladium, silver, copper, zinc, and nickel. As the mixture gets to be less gold and more of those others, though, it usually gets a lighter and lighter color. So that's how people could tell if you were wearing a 10 karat gold necklace versus a 18 karat gold necklace. It just wouldn't be quite as yellow. Over time, people realized that there was more metal trapped in the rocks that crushing and melting just couldn't get out, because the metal was trapped in these mineral compounds as things that didn't look like the metal, like copper carbonate is bluish and green. Iron can be trapped in reddish rocks, that's hematite, or it can be trapped in these fool's goldy looking rocks as pyrite. So they realized that they needed another way to get the metals out of the rocks, which resulted in a whole lot of cool chemical reactions.